This will be the last thing that we'll go and pick up from that review chapter. I just wanted to make sure that we had this before we started getting into some of the solving inequalities and things like that, because probably the important thing from here, or one of the important things from here, is going to be that set builder notation, so that we can understand when we see that written later in the book, we kind of understand what that is referring to. So just a couple things to cover, little quick reminders. So some vocabulary terms to look at. A set is simply a collection of objects, and we can refer to those objects as either being elements or members of that set. Sorry, that's kind of far down on there. So the braces, kind of little curly braces, are what we use to enclose those elements. A finite set is going to be a set that has a definite ending. So if you notice there, the example is 1, 2, 3. It has just those three elements, 1, 2, and 3. Whereas when we look at that infinite set, it doesn't end. It's 1, 2, 3, and so on. So I don't have a specific number of elements in that set. If we have a set that contains no elements, then we call it either the empty set, or we sometimes refer to that as the null set. That was where that empty set symbol we used for no solution came from. You could also use a set of braces and just don't put anything inside of the braces. This weird little kind of curved E just means is an element of. So here we can say 2 is an element of that finite set 1, 2, 3. So actually going over then, like natural numbers are number sets. So natural numbers are essentially our counting numbers. So if you were to naturally start counting, you're looking at things like 1, 2, 3, and so on. Whole numbers, we start to include 0. Still nothing on the other side, so we start at 0, 1, 2, 3, and so on. Integers, then, we start to get the inverses of each of those natural numbers. So integers are when we start to include negatives. Zoom out just a smidge. Rational numbers, then, are when we include fractions. This means that you have some decimals. So like you could have 1/2, you could have 3/8. This is where you could put 0.25, because 0.25 can be written as a fraction 1/4. If you have a decimal that cannot be written as a fraction, then it's not going to be included as our as our rational numbers. So irrational numbers then are the ones that cannot be written as a fraction. Those would be things like pi or maybe square root 7. Be careful to not think that just because you see a square root sign in a problem that is automatically an irrational number, because square root of 16, for example, is 4. And 4 would be classified as a natural, a whole, an integer, and a rational number. And then real numbers are made up of rational and irrational. We do have non-real numbers. For example, our imaginary numbers, and those we'll get to a little bit more second semester. This is just kind of a visual of those sets and how they build on each other so that you can kind of see the integers completely contain the whole numbers and completely contain the natural numbers. I can't come up with a natural number that's not also an integer. However, I do still have some space over here in the green for the rational numbers that's not included within the integers. So again, it just kind of gives you that visual on these sets just continue to build on each other. Then rational and irrational, those are two completely separate sets. So notice there's no overlap there. And then the two things, the green box and the blue box together, make up our real numbers. So that was kind of the first half of this lesson. The second half is looking at set builder notation. Hopefully you can kind of see it's color coded there. So when we see set builder notation, when we see the curly brackets, that tells us that we have the set of. This is saying that we're looking at elements x, and that line there just means such that, and then we have x to have some kind of given property. Right, we will look at some examples. Sorry, I just wrote all over my finger. Got most of it off. All right, so we'll look at some examples. Again, if you need some additional time to get this copied down, that's the beauty of the videos, is you can always pause at any time. Sorry, that was kind of noisy. All right, so we want to list the elements of each set. So this says the set of all x such that x is a natural number less than 4. Remember that natural numbers start basically at 1 and continue on to positive infinity. So we're looking at x being a natural number less than 4. That could be 3, 2, 1. It's less than, not less than or equal to, so I will not include 4. And again, 0 is not included in that set. The set of all x such that x is one of the first 5 even natural numbers. So first off, we need to make sure that we realize we are looking at natural numbers. And then here we added that extra part to the property that they are even natural numbers. So again, natural numbers are 1, 2, 3, 4, and so on. Looking only at evens, we're looking at 2, 4, 6, 8, 10. So here again, we are looking at a natural number. So that is something about the properties. And again, we kind of had that natural number part up here, and then we had the less than 4 up here. So notice that when we're looking at x has some given property, that property has 2 parts to it. One of the parts is what kind of number are you dealing with, and the second part is what is the additional information that kind of describes that number. So in this case, we're looking at greater than or equal to 7. So in this case, we are equal to, so we can start here at 7, 8, 9, 10. Natural numbers do not end, and it didn't tell me that I had to be less than a certain point. So this is going to be an infinite set, and it would just keep going. Now we're going to do the flip over here. This time we're given the elements, and we want to try to describe those using our set builder notation. I don't have enough room to write in there, so I'm going to write it down below. So I can start with, it is the set of all x such that, you could use a different variable if you would choose to. I have to describe what kind of numbers I'm dealing with, what number set they come from, and then additional information that can narrow it down to just being the 1, 3, 5, 7, 9. So it's just these 5 numbers. If you want, we could pick something similar to what we have over here with B. These happen to be our even, not even, sorry, those were even. These are our odd numbers. So I might say set of all numbers x such that x is one of the first 5 odd natural numbers. And then I close my brackets. When I look at these here, now I would be careful on this particular one. Like I could describe this as a real number if I wanted to. I could describe these as rational numbers, but if I do something like that, then remember rationals can include decimals, and I don't have decimals here. Since I don't have decimals, I don't want to do rational. Honestly, since I don't have negatives, I don't think I would do integers. Since I don't have 0, I don't even think I would do whole. I think I would take this back to natural numbers. We're only looking at numbers 5, 10, 15, and so on. It doesn't stop. So you might notice those are multiples of 5. So I could say x, the set of all values x, such that x is a x is a natural number. That is a multiple of 5. There are different ways that you could describe these, but that would just kind of be one example.